There is a moment in every C++ developer's journey where the language suddenly stops feeling verbose and starts feeling incredibly powerful. That moment happens when you stop thinking in terms of manual loops and start thinking the way the standard template library was designed to be used. Up to now, in this STL mini-series, we focus on containers. We explore what they are, why they exist, and when to use vectors, lists, maps, and sets depending on the problem you are solving. But containers on their own are passive. They store data, but they don't give you productivity by themselves. What actually unlocks the power of STLs is the connection between containers and the operations you want to perform on them. And that connection is built using iterators and algorithms. Iterators are the mechanism that allows you to move through a container safely and consistently, one element at a time without needing to know how the container is implemented internally. You can think of an iterator as a smart pointer that understands how to move forward, how to access values, and how to know when it has reached the end. Once this idea clicks, something important happens, because every STL algorithm is built on top of iterators. Sorting data, searching for values, counting elements, finding minimum and maximums. All of these operations work the same way across different containers, not because C++ is doing something magical, but because algorithms do not care about containers. They only care about iterators. In this video, we'll start by looking at iterators in a very practical and beginner-friendly way, including how to retrieve values from containers like sets where indexes simply do not exist. Then we'll open the algorithm header and see how a small set of powerful functions can replace large blocks of manual looping code, while making your intent clearer and code easier to maintain. This is where C++ becomes more expressive, not more complicated. Welcome to the Game Creator Accelerator. I am Tony Munoz. To support this channel, like, subscribe, share, comment, and ring the bell so you don't miss the next chapters and open your world to using this knowledge to create video games in Unreal. And if you want to start your first third-person shooter, look the link in the description where I started a game from zero named Mad Gameverse that you can follow step by step to learn and create your own. Now, let's get started. Iterators are like the glue that connects containers and algorithms. An iterator is like a smart pointer that knows how to move through a container. For example, a set does not use indexes like a vector. Let's create an set here, include set, and let's create a set like a standard set and insert these values by default. As we covered in the previous sessions, you can use that mySet and trying to retrieve something using brackets like this. This is not possible. You can see in the suggestion this will cause a compilation error because stdset does not support the operator with brackets. Why it doesn't support it? Because sets store elements in sorted order, but they are not sorted by position like a vector. So the way that we retrieve values is by using iteration. An iteration means go through each value one by one. A simple way to do an iteration would be something like for integer id in a mySet, review every value and present it. This prints every value in the set, and since a set is always sorted, they come out in order. Let's do some variations for this example. First, let me just define the set, and now let's add values. So let's say I'm going to add 10, then I'm going to add 5, then let's use 20, 15, and now I'm going to repeat a value, let's say the 20 again. In principle, I am adding 5 different values, but 2 of them are the same. When I iterate through this set, 2 things will happen. First, the repeated value will be removed, and the second is that it will present the set in order. Let's test it. And here you have 5, 10, 15, and 20. Now that we understand the concept and importance of the iterators, Could it be a better way or a faster way that C++ provides to make this even faster? The answer is yes, and this is called algorithms. Algorithm is where productivity jumps. STL algorithms works with any container because they only care about iterators. They can do tasks immediately without us to having to create a lot of line of codes. Let me present it with one example. First, to use algorithm, include algorithm. Now I'm going to comment this section to create a new group of code. Let's add a simple vector of numbers. Start with std and let's create a vector of type integers and let's call this scores and let's add some values like this group of numbers that we have here. In fact, this is perfect because they are unordered. And because we're using vectors, I have to include vector. Now let's say that like in the other case, I want to sort this vector. For that, I will use std sort scores begin and scores end as two parameters. These will sort the numbers from smallest to largest. And the good thing is that all algorithms works by reading from begin to end. Let's now present this vector sorted. Let's start with std. I will say cout, and I like the suggestions, score in ascending order. And now let's add a for integer s inside scores, present the value, and also I want to add a jump line for what I want to add later on. And now let's run it. Here we have our vector. You can see it is ordered 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Now let's do another operation. Let's say that I want to find a specific score. Let's move some space. Let's say that the target score that I'm looking for is 70. Then I will use this line of code with the command find, which will cover from the beginning to the end of this vector, looking for this target score. And find is part of the standard library. We define auto because we want to obtain that value, whatever this type of value is, and we'll assign it to it. But one important element about the command find is that the standard find does not return the value. It returns an iterator. And when you consider an iterator, you think like an object that points to a position inside the container. So that means that it points to where the value is, not to the value itself. Now, how can we recover this value? We'll compare the pointer to the position in the find, or in the vector, sorry, not in the find, but in the vector. If the position reached the end of this vector, then it means that the value was not found. In other words, if it is equal to a score's end, then it will present that the scored, target score, was not found. But if it reaches a point where the score is different to a score's end, then the value is found. And the way to obtain that value is using asterisk it. The asterisk operator means give me the value at the position these iterators point to. Just to remind you this concept that we covered in previous sessions, imagine a house address and a mailbox. It is the address, and asterisk it is the mail inside the mailbox. You don't print the address, you print what's inside that address. That is what it also calls dereferencing, using the asterisk it. Dereferencing means accessing the value stored at the location the iterators points to. Before we continue, let me share something important with you. This channel is part of a bigger experience that we offer with the Game Creator Accelerator Lifetime Mentorship Program. And the goal is simple, a real transformation in just a few weeks that you can carry for the rest of your career as a game developer. You and I work together to build your first playable prototype in Unreal and develop a deep understanding of the principles you will use in the future projects that you will create. We also set up your social media platforms so people actually notice your work, and we create a daily routines and strategies that keep your inspiration high and your progress visible. This is the same approach that successful independent creators use to turn small projects into real opportunities. It helps you start shaping a business model around your game, while also positioning yourself for studios roles if that is the path you want to take. Because in today's industry, sending applications is not enough. You hack the system by showing consistent progress, sharing what you create, and letting studios or players come to you. And you won't be doing this alone. You will build your own brand, be part of a focused community, and have my support week after week with lifetime access. If you want to know more, check the link in the description. Visit woolen.com, learn more about the program, and set a one-on-one chat with me. Remember, this is the Game Creator Accelerator Lifetime Mentorship. Other two common operations I want to introduce are the count, which is used to count occurrences of a specific element, or in this case of our score. Let's say that I want to find how many times the score 50 is presented. To count the occurrences, we use the standard count, and we define, of course, the scores begin, scores end, and the score that we are searching for. Now let's present this value. The value that we added, which is the count, it is here, and we are just going to use the standard cout to present it. Let's run it. And here we have one occurrence. Let's say that we are going to add again another 50 here. Go to the bottom and run it again. And now we have 2 times or 2 occurrences. And finally, the iteration through values. In this case, for each element, let's say that I want to cover all the elements of this vector and print its square. Let's start with a comment. And then we do the for each. The for each notation is straightforward again. We start with the scores begin, scores end, and then we add what is called a lambda expression. A lambda is a small unnamed function you can define directly where you use it. You can see that we don't have another closing parenthesis here to complete the for each and then starting the curly braces. This is all part of the same thing. And then we have this end parenthesis that close the initial for each. But the power of this process is that I am iterating through all these elements using this simple command. Now let's run it. And here we have it, 100, 400, and so forth. All these algorithms work even if you replace the vector with a list, a set, or any other container. Algorithms don't care what container you use. They only care about the iterators. And that, of course, makes your code simpler, faster to write, and more consistent. This is your first real step into the power of STL. The more you practice, the more you will see these containers and algorithms everywhere in modern C++. Next time you need to store data, search for something, or process a collection, reach for the STL first. It will make you faster, cleaner, and far more productive as a game developer or a developer in C++. Like this video, subscribe to the channel, leave a comment, and share this series with someone starting their journey in C++. And remember, visit woolen.com to learn more about the Game Creator Accelerator Lifetime Mentorship Program for career transitioners to game developers. And yes, it is not too late to start carving your path. And yes, it is designed to do it after office hours. Until next time, keep creating, keep sharing, and most importantly, keep dreaming big. I'll see you soon, my fellow creators.